Welcome to The Explainer. Today, we're diving into one of the biggest questions out there. How do you actually teach an AI to reason? We're not just speculating. We're going straight to the source with a new paper that gives us a real roadmap. So, we've all been pretty blown away by AI lately, right? It can write code, solve incredibly complex math problems, even whip up some poetry. But all this amazing performance begs a fundamental question. Is the AI genuinely reasoning its way to an answer? Or is it just doing a super advanced form of mimicry? Just stitching together patterns it's seen before. And this is the core mystery. Are we building AIs that can actually apply principles to totally new problems? Or are we just creating really, really sophisticated parrots? Getting this right is the key to building AI that we can actually trust.
Okay, let's get into it. We're going to walk through the key findings from a groundbreaking paper out of Carnegie Mellon University that basically lays out a clear plan for teaching an AI to reason. We'll cover the big mystery, the brilliant experiment they set up, and the 4 key rules they figured out along the way.
So first things first, we need to wrap our heads around the central debate. When we fine-tune one of these huge AI models with new data, are we actually teaching it new skills, or are we just kind of sharpening the abilities it already picked up from scraping the internet?
The research community is honestly all over the place on this. Some folks argue that fine-tuning doesn't really add any brand new capabilities. But then you've got others showing what looks like really strong evidence that these models can learn to solve problems way beyond what they saw in their initial training. So, who's right?
Well, to get a real answer, researchers at Carnegie Mellon's Language Technologies Institute knew they had to get rid of all the chaos of messy internet data. They needed a totally controlled environment, kind of like an AI sandbox, to see what was really going on under the hood.
So instead of using all that unpredictable data from the web, they created their own synthetic world full of math problems. This was the game changer, because it let them control every single variable and figure out what actually teaches an AI a new reasoning skill.
This setup is just brilliant, because it meant they could see not just the final answer, but the AI's entire thought process step by step. They could control the difficulty, they could watch every single step, and they could systematically change the training data to see what worked. This is how they uncovered the rules.
All right, let's get to their first huge finding, something they call the Goldilocks zone for AI learning. And it turns out just throwing more and more data at a model, well, that's not the answer.
The big idea here is that real, genuine learning only kicks in when you challenge the AI with problems that are right on the edge of what it can do. Stuff that's difficult, but not totally impossible.
And this chart just illustrates it perfectly. Check out that orange line. That's the one they call RL on OD mid. When they trained the model on these problems that were moderately difficult, just outside its comfort zone, boom, a massive jump in performance. The other methods, they barely move the needle.
It's exactly like teaching a person, right? If a problem is too easy, the model is bored. It learns nothing. If it's impossibly hard, the model just fails over and over and learns nothing. But if it's just right, in that sweet spot of difficulty, the AI is forced to stretch and actually develop brand new reasoning skills.
Okay, so if the Goldilocks zone is where the learning happens, what does the AI need to know before it can even start? And that brings us to rule number 2, you've got to plant the right seeds.
So take a look at the first chart on the left here. When the AI had absolutely zero previous exposure to a new type of problem, it was a complete failure. No matter how much they tried to teach it, performance was stuck at 0. It just had no foundation to build on.
But now, look at the crazy difference in the third chart. Here, the researchers gave the model just a tiny 1% exposure to the new problem's basic concepts. With just that little seed planted, the model could suddenly learn and generalize, and eventually it was solving even the most complex problems.
I mean, this is a massive insight. It means you don't have to pre-train an AI on every single complex thing it's ever going to see. You just need to give it the basic building blocks. Even a tiny 1% exposure, and it can use that foundation to build much more complex reasoning on its own later on. So we have pre-training to plant the seeds, and then reinforcement learning to challenge the model. But the study found this crucial and often overlooked step in the middle that they call mid-training. This chart makes it super clear. With the exact same amount of computing power, a strategy that includes this mid-training phase, that's the blue line, just crushes reinforcement learning by itself, which is the yellow line. I mean, the performance gap is huge, especially on the harder stuff. So why does this matter?
Well, because it's just a much more efficient way to train AI. This mid-training step uses higher quality data to act as a bridge between general knowledge and specialized skills. It installs the key concepts, which makes the final reinforcement learning stage way more effective. You get better results with less work.
Okay, last but not least, let's look at the fourth rule. And this one is all about how we give the AI feedback. As it turns out, how the model gets to the answer is every bit as important as the answer itself.
See, the normal way to do this is to only reward the AI if it gets the final answer right. The problem is this leads to something called reward hacking, where the AI finds some clever shortcut or exploits a weird pattern to get the right answer without actually reasoning. The solution? Reward the process.
And the results are crystal clear. By rewarding the AI for showing its work, for following the correct logical steps, the researchers saw a significant 5.2% jump in its ability to solve the hardest problems. This pushes the AI towards faithful reasoning and, honestly, just makes it way more reliable.
So, to wrap it all up, this research gives us this amazing 4-part playbook. Number 1, train the AI at the edge of its competence. 2, make sure you plant those seeds of basic knowledge, even a tiny amount. 3, use that super efficient mid-training step to bridge the gap. And 4, reward the reasoning process, not just the answer.
You see, these principles aren't just about settling some academic debate. They give us a practical roadmap for building AI that's more capable, more reliable, and more trustworthy. It's about shifting from just making models bigger to making them smarter. And that leaves us with a really exciting question. What are the grand challenges we should point them at first?